For 50 years, we've dreamed of returning to the moon, but nobody's talking about what happens after we land, because surviving there isn't about rockets. It's about power. How do you keep a base alive where the night lasts 2 weeks, and a single mistake means death? The answer isn't on Earth. It's buried in the moon itself. The moon may look peaceful from here, but it's one of the harshest environments imaginable. No air, no atmosphere, no weather. And its day-night cycle lasts nearly 29 Earth days. 2 weeks of blazing sunlight followed by 2 weeks of freezing darkness. For future astronauts, that means one huge challenge: keeping the lights on. The first idea is obvious: solar panels. Sunlight on the moon is pure, strong, and constant during the lunar day. NASA plans to build solar farms near the South Pole, where sunlight shines for most of the year. But once darkness falls, those panels become useless. Imagine your entire base losing power for 350 straight hours. That's not just inconvenient. It's deadly. To survive that darkness, scientists are developing what they call lunar batteries. These massive storage systems could trap solar energy during the long days and release it slowly through the long nights. They might use molten salts, advanced metal batteries, or even cryogenic fuels buried underground. But storage alone can't power a colony. So NASA's next move? Something stronger. Deep inside NASA's labs, a project called Fission Surface Power is taking shape. It's a compact nuclear reactor, about the size of a car, designed to run for 10 years without refueling. No sunlight needed, no moving parts, no maintenance. If the sun fails, this little reactor keeps the moon alive, and it's not theoretical. NASA and the Department of Energy plan to test the first prototype on the lunar surface this decade. But there's an even more mysterious source of power, something the Apollo astronauts never realized they were walking on. It's called helium-3, a rare isotope carried by the solar wind and trapped in lunar soil for billions of years. If humans can harness it for fusion reactors, helium-3 could generate enormous amounts of clean energy. No radiation, no waste. Just 1 ton could power a city for years. And the moon? It might hold over 1 million tons. In 2022, China's Chang'e 5 mission brought back lunar samples. Inside them, scientists discovered a brand new mineral, Changasite Y. It contained traces of helium-3, proving that the moon really is a potential energy treasure chest. It's the first new mineral found on the moon since Apollo, and it could ignite a new kind of space race, not for land, but for energy. Other scientists are dreaming even bigger. Imagine solar farms built on the bright crater rims, beaming power through microwaves to bases hidden in darkness. No wires, no batteries, just wireless energy flowing across the lunar surface. Others are exploring hydrogen fuel from lunar ice, advanced fuel cells, and even static electricity from moon dust. On the moon, even impossible ideas get tested, because energy is more than survival. It's independence. If we can power a base on the moon, we can live there permanently. We can mine, build, research, and explore. And once humanity can live off the land on another world, Mars won't seem so far away. The moon may look lifeless, but it's hiding the keys to a new age of energy, from sunlight to nuclear power, from buried helium-3 to crystals that might one day fuel our future. The moon isn't just a destination, it's the battery for humanity's next chapter. Because in the darkness of space, power isn't just survival, it's destiny.